Hello, my name is Professor Kaysen, and welcome to the DMAT 0305 final review. Today we'll be working on the 20 questions that are going to be on our last exam, working out 2 examples of each question. So let's go ahead and get started on our first problem. Alright, so for our first problem here, we have the circumference and area of a circle. We start off with our radius of 9, and we have our 2 primary equations we need to remember. Area is pi r squared, and circumference is 2 pi r. So what we want to do is we want to start off with these 2 bits of information here. We're going to say A equals pi times 9 squared, and this is 81 pi. So that's our area to start. Then we have our circumference is 2 pi r, and r is 9, and this is 18 pi. So here we've got 81 pi for our exact area and 18 pi for the exact circumference. The reason these are exact is because pi is an exact value of pi. We don't estimate it as 3.14 or anything like that. This is pi with all of the digits. So this is the exact area, and this is our exact circumference. Now for the approximate area, what we're going to do is we're going to actually utilize the calculator here and put in 81 pi, and that gives us this 254.469. So for that, our area is, once again, 254.469. And I should have actually made these squiggly because this is approximately. Now, it also says to round to the nearest hundredth. And our nearest hundredth is our second digit here after the decimal. So this is really going to be rounded to 254, sorry, 0.47. Similar for our circumference, we're going to go ahead and plug in those numbers into our calculator. So we have 18 pi, which is 56.54. Given that we're estimating to this 4 here, and there's an 8 right after it, that's going to be 56.55. So we're going to go ahead and write out that our circumference is approximately 56.55. Now I would like to note that these all are missing the meters. So this one is actually 56.55 meters. This is 254.47 meters squared. And then for our exact ones, once again, area is meters squared, and circumference is meters. So those are going to be all the information that we have once we put this in. So we have 81 pi here, we have 18 pi there. The approximate area we got was 254.47 meters. We should include our, meter squared. Meters squared, I said. 254.47 meters squared. 81 meters squared, 18 pi meters, and 56.55 meters. Here you can see the check shows that it's correct, and we can see that we did our problem correctly. So let's go ahead and try another one of these just to get a little bit more of a feel and comfort of this. So here we're given the diameter is 10 feet. Now, once again, let's go ahead and write out our equations that we need. Our base equations are, once again, a equals pi r squared, c equals 2 pi r, and in this case we should remember that our diameter is actually just twice the radius, so 2r, which means we could actually write this as pi d. Since our diameter is 10, our radius, since this is 10, our radius is 5. So let's go ahead and go back to our exact area. Our exact area A is pi r squared, r being 5, which is 25 pi. Then our circumference is just pi d. So it's just 10 pi. Feet for this, feet squared for that. And when we do our actual area, remember that area, we just need to write it out or calculate it out, and then we can go ahead and write that out. So let's bring our calculator over here. We're going to have 25 pi. That's 78,539. Because we're rounding to the nearest hundredth, we're going to round that 9 up to a 4, or that 3 up to a 4. So our actual value is going to be, our approximated value is going to be 78.54 feet squared. We're going to do the same thing for our circumference. 10 pi. We get 31.415. Because of this 5, we're going to round that 1 up to a 2. So we get C is approximately 31.42 feet. Let's go ahead and put it in and check just to make sure that we are doing everything right. Don't forget your units. We have 78.54 feet squared here, and circumference here will be the 31.42 feet. Do a check, and you can see we got it right again. Now I would like to note, it doesn't always ask for area then circumference, so make sure you are checking what you're reading rather than just doing calculations and putting your numbers in the boxes you think they go in. Remember to make sure you're paying attention and you put them in the boxes they belong in. With that, we're going to go ahead and move on to our next problem. So here we have the second problem in our problem sets. We have a piecewise rectangular figure, and we're looking to find the area of the figure. To do this, we're going to break the figure up into pieces. So we're going to go ahead and cut off right here and right here, and look for the area of these 3 different rectangles and add them all up. Now for us to find these edges of the pieces that we're missing, for example this red one, we don't know what that is. However, we have a 2 here, and we know that the full length of this is 5. So 2 plus 3 equals 5. Since these are parallel to each other in the same length, we're going to go ahead and put a 3 there. And then over here we have 3 different bottom parts. We have, this one's going to be 3 because the top part's 3. This one's also going to be 3. And this one, because this part here is 3, this is also 3. So each of our rectangles have a different thing here. We have 5 times 3 here, so this is 5 times 3, which is 15. This is the same thing, 5 times 3, which is 15. And here we're going to have 3 times 3, which is 9. So our total area for everything is going to be 15 plus 9 plus 15, which equals 39 yards squared, because every single one of these is a yard squared. So if we go ahead and we put that in over here, 39 yards squared, we hit check. You can see we did everything right. Unfortunately, this pushes it down and everything's not lined up anymore, but that's okay. You can go back in the video to see where things were before we hit the check. Let's go ahead and do another one of these before we move on to our third question. So here we have another piecewise figure, and we're going to cut it across here because it's the least number of cuts that we need to make. This part here, we already can see there's a 5 there and a 4 there, so this is just going to be 5 times 4 is the total area of this. 5 times 4, and this is 20. For us to be able to determine our bottom rectangle here, though, we need to figure out this length here. So we have 5 here, 5 here, and 4 here. Well, all of these across are going to add up to this one, especially since this part here, this red line here, is also 4. So 5 plus 4 plus 5 is 14. That means that this bottom here is 14. So we have 14 times 3. And that equals 42. So our total area, when we add everything up, is going to be 20 plus 42, which equals 62 yards squared. And let's go ahead and do our check. 62. So you can see, especially with the way that this pushed down everything, you can see that this 4 still lines up with the rectangle, and that's how you definitely know that if you slid this all the way down, you would still have a 4 here. It really does give you a good sense of how to measure these things. All right, so that's going to be it for the second set. Let's go ahead and move on to our third. All right, here we have our problem 3, which is going to be based on the Pythagorean theorem. Now, if you recall our Pythagorean theorem is a squared plus b squared equals c squared. In this case, it doesn't really matter which one of these pick as a. What we're going to end up doing is we've got x squared plus 16 squared equals 20 squared. Now, since we're trying to solve for x, we need to move everything else to the other side. So let's go ahead and subtract 16 squared from both sides. And we get x squared equals 20 squared minus 16 squared. Now, just in case you don't know these off the top of your head, you can use your calculator here. It's fine. No really good spacing for this, but we have 20 squared is 400. And when we subtract 16 squared, we're going to get 144. So x squared equals 144. If you square root both sides, you're going to get x equals 12. And that's how we do these problem sets. Let's go ahead and look at one more, and then we'll move on to problem 4. So here we have another Pythagorean theorem. Once again, it's a squared plus b squared equals c squared. you're going to say 12 squared plus x squared equals 16 squared. It doesn't really matter if you say x squared or 12 squared first. You're going to end up getting the same results. Subtracting 12 squared from both sides. This gives us x squared equals 16 squared minus 12 squared. If you want to do your calculations, pull up your calculator. 16 squared is 256, and 12 squared is 144 minus 12 squared, and we get, wait, I gotta write something wrong. 256 minus 144, no, it's 112. It gives us 112. So we have x squared equals 112. When we square root both sides, because you need to square root both sides, we're going to go ahead and put into our calculator here square root of 112, and it gives us 10.583. This is round to the nearest hundredth. Since the 3 is less than 5, we're just going to keep the 10.58. And that's all there is to it. So let's go ahead and move on to the 5th problem in our problem set. So for problem set 5, what we're doing is we're just simply going to be combining like terms in a quadratic expression. Here what we want to do is we just want to see what like terms we have. So starting with our x squared terms is what we have. Then we'll look at our x terms. And then we'll finally look at our constant terms. Now looking at these, we can see we have the 11x squared and the 9x squared, but this is a minus 9x squared. So that leaves us with 2x squared. Then we have the plus 10x, nothing else to combine with that. And then we have the minus 8, minus 11. When we put those together, we get a minus 19. Let's go ahead and look at one more, and then we'll move on to problem 6. Oh, I skipped one. I skipped 4 on accident. I'll have to redo that one. It's fine. All right, so here we have our next one. We're going to look at, once again, since we're combining like terms, let's just look for our like terms. The x squareds have like terms. The x and the 3 don't have any like terms. They are just by themselves. You can see there's only one x term here, none others, and there's only one constant term here, nothing else. So given that, we're just going to say the 8 minus 10 is negative 2. We have x squared. And then the 2x is by itself, plus 2x. And then the minus 3 is by itself. All right, and so that's going to be it for that problem set. Let's go ahead and move on to the next thing. All right, here we are trying to calculate the distance between 2 points. We have a point here, h at 0, 3, it's this one, and j at negative 3, negative 5, which is this one. And what we're trying to do is find the distance between the 2 points. To do that, what we're going to really be doing is utilizing our Pythagorean theorem. We will determine sort of, actually, no, hold on. No, let me redo this problem. Let me redo this problem from scratch. Take 2. So for this problem set, we're calculating the distance between 2 points on a plane. We have our point h, which is 0, 3, and j, which is negative 3, negative 5. And we're looking to find this distance. Now recall that we had actually developed this using the Pythagorean theorem, and we get something like this. D equals the square root x2 minus x1 squared plus y2 minus y1 squared. And we're going to put all that into our calculator. But first we need to kind of write down our numbers and what we need. So we're going to go ahead and start with h as our 1, x1 or x1 y1, and j as our x2 y2. You can do it in either direction, it doesn't really matter. So if we start with x2, this is minus 3 minus 0, which is a negative 3. And then we have negative 5 minus 3, which gives us negative 8, but we're squaring all that. So when we put everything in, we're going to get the square root of 9 plus 16. Negative 3 squared is 9. Negative 8 squared is 64, not 16. 64, which is the square root of 73. So our distance is the square root of 73. And if we put that in our calculator, square root of 73, we get 8.544. It wants us to round to the nearest hundredth. So we're going to put in 8.54. All right, let's do another one of these, just to kind of get this a little bit of a better feel, and then we'll move on to our next problem. All right, so here we have our problem for problem 2 on this problem set. Let's go ahead and remember that since we're doing the distance formula, we need our distance formula. Let's write that out. D equals square root of x2 minus x1. Square that, plus y2 minus y1 squared. And if we go ahead and start inputting our numbers into that, we've got that this equals the square root of negative 1 minus negative 9 squared plus this 7 minus 3 squared So when we go ahead and do our calculations, negative 1 minus negative 9 is the same thing as negative 1 plus 9, which gives us positive 8. And 7 minus 3 is 4. Eight squared is 64. And 4 squared is 16. 64 plus 16 is 80. So we're looking at the square root of 80. Which is 8.94. So we're going to go ahead, 8.94. Hit check, and we got it. All right, that's going to be it for this problem set. So let's go ahead and move on to the next. All right, here we have our next problem set. We're going to go ahead and multiply these out. So all we really need to do is just distribute this whole thing here to each of these terms. So really what we're looking at is 10x squared times 7x to the 4th minus 10x squared times 5x cubed. This minus here comes from the minus here. That's where those come from. Now, if we went ahead and multiplied everything out, the first one we have the 10 times 7, so that's 70. And then x squared times x to the 4th is x to the 6th. Then we have here our 10 and 5 gives us 50. X cubed times x squared gives us x to the 5th. So our answer that we put in here, 70x to the 6th minus 50x to the 5th. All right, let's go ahead and look at another one before we move on. So here's our next one. Once again, we're going to do the same thing. We're going to take this and distribute it to these. So you'll see we've got 2z to the 5th times 10z cubed minus 2z to the 5th times negative 8, or times, so you wouldn't actually do that negative 8. So it's just 8. If you wanted to do the negative 8, you'd have to make this a plus and this a minus. So let's go ahead and calculate these out. We have 2 times 10 is 20. Z to the 5th and z to the 3rd is z to the 8th minus 16z to the 5th. Since there's no z here, we don't have to worry about it affecting this z to the 5th. So we're just left with 20z to the 8th minus 16z to the 5th. Let's go ahead and put this in. 20z to the 8th minus 16z to the power of 5. All right, so let's go ahead and move on to the next problem set. All right, here, so we're going to be multiplying our binomials. I'm going to go ahead and use the box method for this. So first, we're going to go ahead and make our box. Everything lined up on the thing, but it didn't line up on the paper. Let's restart. All right, so here we have two binomials that we're going to be multiplying together. So we're going to start by drawing a box. And we're going to put u minus 1 and u plus 3 on the outside. Then we're just going to multiply everything on the inside. This is u squared. This is minus u, 3u, minus 3. And then we're just going to add everything together on the outside. So we've got u squared minus u plus 3u minus 3. These middle terms here simplify down to just 2u. So this is going to be u squared plus 2u minus 3. Let's go ahead and put that in. U squared plus 2u minus 3. And there you have it. Let's go ahead and do one more of these, and then we'll move on. All right, so here we have u plus 4 times u minus 5. Once again, we're going to use our box method. U plus 4, u minus 5. First one's going to give us u squared plus 4u minus 5u minus 20. Writing it all out, we've got u squared plus 4u minus 5u minus 20. This simplifies down when you combine all your like terms to u squared minus u minus 20. We're going to go ahead and put that in. U squared minus u minus 20. All right, and that's going to be it for our 7th problem set. Let's go ahead and move on to our problem set 8. All right, so here we have our problem set 8, and we're multiplying a binomial with a trinomial. So once again, I'm going to go ahead and use my box method. We're going to say it's going to be a 2 by 3. We're going to do 4w squared, 3w, and then 6. And then here we're going to have 7w minus 5. So once we go through all of these, we're going to start with our 4 times 7, that's 28. W cubed. 3w times 7w is 21. W squared. 7 times 6, 42w. 5 times 4 is 20 minus 20 w squared. 5 times 3 is 15, so minus 15w. And then negative 5 times 6 is negative 30. Then here we're going to write everything out and add it all together. We're starting with 28w cubed plus 21w squared plus 42w minus 20w squared minus 15w minus 30. Then, putting all our like terms together, which I've already kind of put nicely in rows, we end up with 28 w cubed minus 21 minus 20 is just 1, so that's going to be a plus w squared. 42 minus 15, that's 27. And then we have our minus 30 over there. And so this will be our solution. 28w cubed plus w squared plus 27w minus 30. All right, let's go ahead and do one more, and we will be moving on to the next one. So here we've got another binomial and trinomial, so we're going to go ahead and do the same 6-box figure. So we're going to do 3u minus 7, 4u squared minus 5u plus 2. Let's go ahead and multiply everything out in the inside of these boxes. So 12 times 4, or 3 times 4 is 12. Cubed, 3 times 5 is 15. U squared plus 6u minus 28u squared plus 35u minus 14. Writing everything out, 12u cubed minus 15u plus 6u minus 28u plus 35u minus 14. Go ahead and bring our like terms. Gives us 12u cubed minus 30, 43 u squared. That was supposed to be squared. I need to square those. And then 6 plus 35 is 41 minus 14. Let's go ahead and write these out. 12u cubed minus 43u squared plus 41u minus 14. And that's it. All right, so let's go ahead and move on to the next problem set. All right. So for this one, we have a leading coefficient of 1. So this is 1. That means all we have to do is focus on these two numbers here. So what we're looking for are the factors of 15 that when you add them up, you get 8. So in this case, we have a few options. You know, with 15 could be 15 could be 1 and 15, or 3 and 5. But we know 1 and 15 is not going to work because when you add those together, you get 16, so it's not that one. But when you add these together, you get 8. So we're going to go with this one. So our solution is simply going to be x plus 3 times x plus 5. You can do this using the AC method, but it's unnecessary. You're really just grabbing each of these and just putting them into some parentheses with an x. That's really the whole thing. So we're going to say here x plus 3, x plus 5. So let's look at one more of these, and we'll move on to the next. So here we've got, once again, the leading coefficient's 1, so we're really focused on the middle term, this 14 and this 33. Now, since this is positive, but this is negative, we know that both of the factors of 33 need to be negative. That's because the only way to get 33 to be positive is if you're multiplying two negative numbers. So it's either going to be 1 and 33 or 3 and 11. Now, out of these, the 1 and 33 doesn't make sense. It's going to give you 34, or negative 34. This one gives you your negative 14. So what we're going to do is we're just going to go ahead. We're going to grab these. We're going to say x minus 3, and it's because we took this and put it in there as a minus 3, times x minus 11, because this has the negative here, and we took that, just brought it here. So our solution is x minus 3 times x minus 11. All right. So that's going to be that one. We're going to go ahead and move on to the next problem set. All right, so here we have problem 10. Now, if you look at this, we have a 5y squared, so our leading coefficient is 5. So what we're going to be doing is our AC method. We have AC equals 5 times 2, which is 10, and we're looking for the factors of 10 that add up to 11. This center number here. Well, that's going to be 10 and 1, because 10 plus 1 equals 11. And using this, we're going to break apart that 11. So we've got 5y squared plus 10y plus 1y plus 2. Then we want to group these. I'm going to group it like this. And when you do that, we're going to factor out a greatest common factor out of each of these. For 5y squared plus 10y, that's going to be 5y. So we get 5y, and we're left with a y plus 2 plus 1 times y plus 2. Finishing this off, we've got 5y plus 1 times y plus 2. 5y plus 1, y plus 2, hit check. You can see we got it right. So let's do another one, and then we'll go ahead before we move to the next set. So here we have 2x squared and 5. So our AC method is going to be 2 times 5, which is 10. And we have a negative 11 here. So we need factors of 10 that add up to negative 11. That tells me that they're both going to be negative, or because negative 10 plus negative 11, or negative 1, gives us negative 11. And negative 10 times negative 1 gives us positive 10. So we're going to use that to break apart our thing. 2x squared minus 10x minus x plus 5. And then we're going to go ahead and group these. Since this one has a minus here, we want to keep that sign with it, so we're going to plus in the middle between the two sets of parentheses in this way compared to what we've been doing in the past. Now here, our greatest common factor is 2x. So we're going to say 2x, and we're left with an x minus 5. And then when we factor out a negative from both of these, minus 1, we end up with an x minus 5 here. Now let's go ahead and finish this off. 2x minus 1 times x minus 5, and that'll give us our answer. 2x minus 1 times x minus 5. Now you're probably asking, well, what if I didn't do this and we would have put in our parentheses there? It would have came out looking like our groups would have been x squared minus 10x and x plus 5. But if you were to, when you did the factoring, you'd get 2x times x plus 5, or x minus 5, sorry. And then you'd get x plus 5, and that's not right, because you can't factor anything out of that. So you would have ended up just getting yourself stuck and not getting an answer that made any sense. Plus, if you multiply these things together, you get this. All right, so let's go ahead and move on to the next problem. So here we have a trinomial, and it's a perfect square trinomial. So you can do this in one of two ways. You can remember that we have a formula that says a plus b squared is a squared plus 2ab plus b squared. And then you can just kind of recognize that's what this comes out to be. Or you can just do the method where we know this is 9 times 9, and those add up to 18. Either way, you're going to get, if you do this by the factoring using this formula here, we have that the first term is y squared, and the last term is 9 squared. And if we check the middle, we see that this is 2 times 9 times y, which is our 18y. And this tells us that this is simply y plus 9 squared. So because it's a perfect square trinomial, you actually would like, it'd be best for you to put it in like that. Check. You can see we have that. Let's look at another one real quick. So once again, we're going to be using the same formula. We've got A being V. Let me actually grab that marker. A being V. And B being 5. So we put our 5 in there. That's 10V. You can notice that matches here. 5 squared is 25. So this is just V plus 5 squared. V plus 5 squared. Now you're not always going to get a plus plus. If you do get the plus plus, then this is a plus. But let's say if you get this minus plus like this, then you get a minus. So you'd end up with the x minus 8 squared. And I know it's x minus 8 because 16 is 2 times 8, and 64 is 8 squared. But see, now that you have the minus plus, it's a minus here. All right, let's go ahead and look at another problem and continue going forward. So here we have solving an equation written in factored form. Now notice that when you have this 2 factors and it equals 0, we have a 0 factor rule that says if A times B equals 0, then A equals 0 or B equals 0. For this one, we can have multiple solutions because there's 2 different y values that make this true. What we want to say, based on this rule that we have up here, is that 2y plus 1 equals 0 or 2 minus y equals 0. Now, if the first one's true, if 2y plus 1 equals 0, 2y equals negative 1, we just subtracted 1 from both sides, and we can divide out 2 on both sides, and we get y equals negative 1/2. If this one's true, we can simply just add y to both sides, and we get 2 equals y, or y equals 2. So we have the 2 possible solutions of y equals negative 1/2 or y equals 2. Inputting it into our solution here, we would say, let's get our fraction, negative 1/2 or 2. Let's go ahead and look at another one of those, and we'll move on after that. All right, for this one, we're going to do the same thing that we did with the last one. We have 3 minus v equals 0. Okay, you know what? Let me restart this question. So for this one, we're going to do the same thing that we did in the last one. We're going to say 3 minus v equals 0 or 4v minus 2 equals 0. If the first one's true, we want to add v to both sides. And we get v equals 3. or I guess if you want to be exact as what's written here, 3 equals V. And then, you know, that simplifies, or we'll end up writing that as just V equals 3. On the other side, we want to add this 2 first to both sides, and we get 4V equals 2. Dividing out V from both sides, not V, dividing out 4 from both sides, we're going to get V equals 2 over 4, which is the same thing as 1/2. So when we put this in, we have either V equals 3 or 1/2. All right, so let's go ahead and move on to the next problem set. Okay, so here we go. Looking at this, the first thing that we need to consider is we want to look at X and Y. And do they share any things at all? Now, I see A, B, C, D, E, F, G. They don't share anything. So when they don't share anything at all, there's not going to be any overlap like this, which means it's going to look like that. So if we start by putting in the things where they go, A goes in Y, B goes in Y, C goes in X, D goes in Y, E isn't in either of them, so that's part of the universal set, F is in X, G isn't in either, so that's a universal set, H is Y, and X will take I, and you can see that's how you put it together. Remember, the important thing is, since they don't share anything, it is disjoint. Let's look at another one. So for this one, I want you to look here. Y is 3, 4, 6, 7. X is 2, 3, 4, 6, 7. 3 is in Y, 4 is in Y, 6 is in Y, and 7 is in Y. Everything that's inside of Y is inside of X. So we want to have it like this, where Y is inside of X. We'll start with, well, I guess we can actually just do everything. 2, 3, 4, 6, and 7. Everything else goes in the universal set, and we're done. All right, so here we have interpreting a Venn diagram with 2 sets for a real-world situation. Now, what we want to look at is our 2 different rings. So we've got the red ring here, and we've got our blue ring here. We want to remember what's inside of each of those. Now, when it says how many students like comedy, red is our comedy. We have Ivan and Rachel, obviously, but don't forget that Layla and Dan are also in that red ring. So therefore we have 4. How many like comedy or nonsense or both? That's everybody in both circles. That's Ivan, Rachel, Layla, Dan, Isabel, Ravi, and Donna. So that's 7. And then who don't like nonsense? Well, that's everybody outside of the blue. That's Ivan, Rachel, and Milan. All right, so let's look at one more and then we'll move on. Can I move it? Yep. Okay, so here we have different days of the week and different instruments being taught. So how many instruments are taught on Monday? That's everything in the red circle. That's tuba, flute, sax, and oboe, which is 4. How many are taught on Monday or Wednesday or both? That's all of them, so that's going to be 7. All of them inside the circles. And then which ones are taught on neither Monday or Wednesday? That's the things outside the circles. So that's just the heart and the djembe. All right, so let's go ahead and move on to the next problem set. All right, so here we're looking at two sets that are disjoint and the universal set, and we're looking for first D complement. So the complement of a set is everything outside of that set. So everything outside of D, so that's going to be F, H, Q, X, and G. F, H, Q, X, G. Next, we want to find B intersect D. Well, these don't touch at all. So that's going to be an empty set. And now we have everything outside of B and everything outside of D. That's only going to be the stuff in the universal set. So that's going to be F, H, Q, and X. We do check, and you can see. All right, let's look at one more, and then we'll move on. So here, we also have disjoint ones. Let's find one that's not disjoint. So here we have D is a subset of B, and U is the superset of everything. It's the universal set. When we have B intersect D, that's really only the things inside of D, since D is also already inside of B. Remember that this is the only the things that they share. Well, they share P, R, and X. D complement is everything outside of D. So that's going to be H, Q, F, G, and Y. H, Q, F, G, Y. Now here we're looking at the union of B and D is really just B. So B union D, the complement of that is just the things that are outside of B, which is just H and Q. If you have something like this, the intersect is at HX because those are the ones that they share. C complement is just the things outside of C, which is going to be the F, Y, Z, and R. And the complement of their union is everything outside of it, which is F, Y, and Z. Oops. Nope, stop that. F, Y, Z. All right, so let's go ahead and move on to the next problem set. All right, so here we're looking for the vertex, intercepts, and axis of symmetry from the graph. So first we're going to look at if it opens up upward or downward. Here we can see that it's opening downward. Now it's saying to find the x and y intercepts. Notice that it doesn't hit the x-axis at all. So for the x-intercepts, that's going to be none. For the y-intercepts, we want to look at here at the graph, and we can see that it's -6. Our axis of symmetry, that's where our vertex is. So our axis of symmetry, remember that that's a full line that passes through the middle here. And this is actually has an equation of x equals. In this case, it's x equals -3. So when we go down here, our axis of symmetry is x equals -3. And our vertex point is going to be that -3, comma, and then if we look here, once again, that's at -2. So this is -3, -2, -2. We hit check. Show you everything is good. Let's go ahead and look at one more of these, and then we're going to move on. All right, so here we have it parabola facing upward. So this one we know it's opening upward. Our vertex is this point here. If we look down at this point, that's -1, -9. -1, comma, -9. This also tells us our axis of symmetry is at x equals -1, so we can go ahead and put that in. X equals -1, because that is the x coordinate of our vertex. For our x-intercepts, we have two x-intercepts. The two x-intercepts are going to be at -4 and +2. -4 and +2. And our y-intercept, if we look at this, is at -8. -8. All right. So that's going to be it for that one. Let's go ahead and move on to the next problem set. All right, so here we're graphing a function of the form ax squared. So here we have f of x equals 3x squared. That's our function that we're graphing. So what we want to look at, it tells us we get to get 2 points on either side, 2 negatives and 2 positives, and x equals 0. So let's go ahead and start making a table. We have our x and our y. And I'm just going to do -2, -1, 0, 1, and 2. So at 0, we know that it's going to be 3 times 0 squared. So that's just 0. For 1, this is 3 times 1 squared, which is 3. And then for 2, it's 3 times 2 squared. 2 squared is 4, times 3 is 12. Then we have the same thing on the negative sides. Well, really conveniently, this is actually symmetric. But we'll go ahead and write it out. 3 times -1 squared. That's -1 squared turns into just 1, so that's just 3. 3 times -2 squared is also 12, because -2 squared is 4. The negatives cancel out because of the square. And what we want to do is we want to input these points on our graph. So we have the points -2, 12. This is the point -2, comma 12. This is -1, comma 3. This is 0, 0. This is 1, 3. And this is going to be 2, 12. So we've got -2, 12, and then 2, 12. We got -1, 3, 3, and then 0 there. So you can see our graph here with the information we had over there. If we hit this button, it graphs it immediately for us by connecting the dots. Hit check, and we're good. Alright, so now let's go ahead and look at this one. We have g of x is -1/2 x squared. We're going to start with the same thing. So when we have 0, well, that's still going to be 0. At 1, we're going to have -1/2 times 1 squared, which equals just -1/2. Similarly, up here we'll have -1/2 times -1 squared, which gives us -1/2. Down here we're going to have -1/2 times 2 squared. -1/2, so first off, 2 squared is 4. 4 times 1/2 is 2, so -2. -2 squared, and it's going to give us -2 again. So we want to go ahead and plot these points. We have 0, 0, 1, 1/2, which we can't plot out here like this. Oh, it looks like it's letting us, but I'll show you the other thing. So then we want to do here, guess I can't move it, 1, comma 1/2, but remember that this is negative. Then we're going to do the same thing on the other side, -1, and then -1/2. Plot that point. And then we'll have -2, -2, -2, -2, and 2, -2. We graph it, and then we check. All right. So that's going to be it for problem 17. Let's go ahead and move on to problem 18. All right, so for 18, what we need to do is we need to use our quadratic formula. Now the quadratic formula is x equals -b plus or minus square root b squared minus 4ac all over 2a. So what we need to do is we need to start inputting all of our stuff from there into here. So first off, a is 3, b is 6, c is -1. Let's go ahead and actually write that down out on the side here. A is 3, b is 6, c is -1. Now we're going to go ahead and input these into our formula here. So we have -b, which is -6, plus or minus, or yeah, that'll be -6, plus or minus the square root 6 squared minus 4 times a times c all over 2a. Let's go ahead and make some calculations here and clean this up a bit. So we have -6 plus or minus square root 6 squared is 36. 4 times 3 is 12 times -1. These negatives are going to cancel out, so we're going to get plus 12 all over 6. So let's go ahead and clean things up a bit. We have -6 plus or minus the square root 36 48 over 6. So let's go ahead and put that in here. We want it to be exact, so it says here exact. It's not asking for you to plug that in the calculator. See, as we don't have a calculator thing over here. If there's no calculator thing over here, do not plug this into your calculator. -6 plus square root of 48 all over 6, comma, oops, I said -6 minus square root of 48 over 6. These are the exact solutions. If it does not give you the calculator on the side, it does not expect you to calculate the quadratic formulas with the decimal answers. You should not have a decimal answer for this. All right, let's go ahead and look at one more, and then we'll move on. So all right, let me erase all of this. And everything's going to get cleaned up, the magic of video editing. All right, so here we have our next problem. We have the 9x squared minus 3x minus 1. We're going to use the quadratic formula again. A is 9, B is -3, and C is -1. So when we're putting these into our quadratic formula, we're going to have our x equals -3 plus or minus the square root negative 3 squared minus 4 times a times c. All of this over 2a. Let me finish off my square root symbol here. Let's go ahead and clean some of this up. Negative negative 3 is just 3. That's 9. 4 times 9 is 36. So, and that negative and the negatives are going to cancel out. So this becomes plus 36. This is all over 18. In the end, when we simplify everything out and clean it up, we're going to end up with just 3 plus or minus the square root of 45 all over 18. And so we're going to go ahead and put that in our answer here. Start with a fraction. 3 plus square root of 45 over 18, comma, fraction. 3 minus square root of 45 over 18. Once again, if it doesn't show you the calculator on this side, it does not expect you to calculate the quadratic formula. It wants the exact answers. The square root of 45 is exact, whereas if we were to have calculated the square root of 45, you'll see it. The square root. Why do you do this? Square root of 45 is this really nasty number here. So that would be the decimal answer. This is acting for our exact answer. So let's go ahead and move on to the next one, which is the decimal answers version. All right, so looking at this one, the first thing that we want to do is we need to change it to ax squared plus bx plus c equals 0. We always need it to be equal to 0 on one side. So what we're going to do is we're going to change this. I'll go ahead and write that at the top to 5x squared minus 9x plus 2 equals 0. That changes our, oops, I didn't erase those from earlier. That changes our a, b, and c. Our a is going to be 5, b is negative 9, and c is 2. So we're going to go ahead and start plugging these into our quadratic formula. We have x equals negative b, negative 9, plus or minus the square root, b squared, minus 4 times a times c. Close that off. All of this over 2 times a. So let's go ahead and clean things up a little bit. So negative 9 is just positive 9. So equals 9 plus or minus the square root, 81 minus, so 4 times 5 is 20, times 2 is 40. All over 10. 81 minus 40 is 41. So this is 9 plus or minus the square root of 41 all over 10. Now that we actually have our calculator, we're going to go ahead and calculate these out. So we're going to start off with our fraction. We have 9 plus square root of 41 over 10. That gives us 1.54. We're rounding the nearest hundredth, so 1.54. And then we're going to do it again. So let's go ahead and do it with the other side. Start off with our fraction. 9 minus square root of 41 all over 10 is 0.259. Because we're rounding to the nearest hundredth, we're going to look at this 9. It shows us to go up, so it's 0.26. Hit check. Let's do one more of these, and then we'll move on to our last problem. All right, so here we have another one. We've got our 2x to the 5th minus 9x plus 5. That tells us that a is 2, b is negative 9, and c is 5. So when we plug this into the quadratic formula, we're going to get negative b, which is negative 9, plus or minus square root b squared, which is also negative 9 squared, minus 4 times a times c, all over 2a, 2 times 2. Let's go ahead and simplify some of this. This is going to be 9, because the negatives cancel, plus or minus square root. 9 squared is 81, minus 4 times 2 is 8, times 5, that's 40. All over 4. Let's go ahead and clean this up one more step. Or actually, we can put it in the calculator as is. You know, that's fine. So we're going to say, start with our fraction, 9 plus square root of 81 minus 40 over 4, 3.85, and then we're going to do the other side, 9 minus square root of 81 minus 40 is 41 over 4, and we get 0.65. 5 comes because this is a 4, the 9 right next to it tells us to round the 4 up to the 5, and that's how we get that. Alright, let's go ahead and look at our last problem, and we will be done. Alright, on this last one, we're going to be graphing a parabola again. So we're going to start with our x and y. It wants 2 points on the left and 2 points on the right of the vertex. Our vertex, when x equals, our vertex is x. All right, so we're going to be graphing another parabola here. So we're going to start with our x and y. This is still going to be centered at 0, with x equals 0. So we're going to go ahead and just do -2, -1, 0, 1, 2. So let's go ahead and put these in. So when we have x squared minus 5, so that's -2 squared minus 5. That's going to be 4 minus 5, which is -1. Here we've got -1 squared minus 5, which is -4. 0 minus 5, which is just -5. And then by symmetry, this is going to be -4 and -1. Let's go ahead and plot our points. And then go. So we have our -5, -4, and -1. Graph, check. That's it. So let's do one more. Here we have x squared plus 2. So let's go ahead and clear out this side here. And then we can just use the same table. When x equals 0, y equals 0 plus 2. Blue. 0 plus 2, which is 2. This is going to be negative 1 squared plus 2 equals 3. And negative 2 squared plus 2. 4 plus 2 is 6. This is going to be 3, and this is going to be 6. By symmetry, let's go ahead and put them in. 2, 3, 6, and 6. We're going to hit check. Oh, got to hit graph. Then we check. And we're good. All right, so that's going to be it for today's review. Thank you for joining, and I do appreciate you. Y'all have a good day. Bye.